By forcing air into the front of it, creating a structured wing, which under the canopy the pilot can fly. Parachutes are controlled by pulling down the steering lines if it's maneuvered by a parachutist, which can change the shape of the wing, causing it to turn or to increase or decrease its rate of descent. The key forces at play here include gravity, air resistance, and terminal velocity. Air resistance refers to the forces that are in opposition to the relative motion of an object as it passes through down the air. These drag forces act opposite to the oncoming flow velocity, thus slowing the object down. Unlike other resistance forces, drag depends directly on velocity, since the component of the net aerodynamic force acting to the opposite the direction of the movement. Terminal velocity, on the other hand, refers to the steady speed achieved by an object freely falling through a gas or liquid. A typical terminal velocity for a parachute that delays opening the chute is about 150 miles or 240 kilometers per hour. Raindrops, on the other hand, fall at a much lower terminal velocity. An object dropped from rest will increase its speed until it reaches terminal velocity. An object forced to move faster than its terminal velocity will, upon release, slow down to this constant velocity.
So we only use 5 materials to build our device. First is the manila paper, which serves as the protector or the container. Second is the pair of metal blade, which is known as the scissor that we use for cutting the edges of the manila paper so that we could achieve the desired shape that is suited for our device. Third is the yarn that serves as a support for the manila paper that was formed into the parachute-like so that it will be anchored to the container-like manila paper. Lastly is the glue and adhesive tape that we use to bond the manila paper and the yarn together. Our device may not be as good as what you expect it to be, but by doing some few renditions, it will be useful one day. That would be all. Thank you.
Our goal is to protect the biological weapon, which in our case is an egg. Our member builds a parachute in order to protect the egg. This parachute consists by a 1/4 size manila paper, 4 pieces of yarn with the same length as the manila paper, and together with the origami box to serve as the container. The result of the egg drop was the parachute was able to withstand and fall slowly, which result to no damage was caused in the egg. Because when you drop the egg, the strings that are attached to the manila paper pull down and spread the manila paper to full size, which create big surface area and more wind resistance. More wind resistance slows down the fall of the egg.